Hello everyone, in this video I will be discussing about the group 17 and group 18 of P block. So group 17, they are also called as an halogen family. So the members will be like fluorine, chlorine, bromine and iodine. The general electronic configuration will be NS2, NP5. They are called as halogens due to their tendency in formation of a salt. So next, physical properties, electronegativity will be more in the fluorine atom than compared to an iodine. So next, electron affinity will be like, chlorine will be greater than the fluorine, greater than the bromine and greater than iodine, in which electron affinity of fluorine is lesser than the chlorine. The reason is why, because due to its small size with an high electron density. Due to the smaller size of fluorine with an high electron density, so chlorine will be having the greater electron affinity than the fluorine. Next, bond length will be like iodine will be greater bond length than the bromine, than the chlorine and than the fluorine. So next, boiling point and melting point increases down the group. Boiling point and melting point increases down the group due to increase in their van der Waals forces. So next we shall look into the chemical properties. In that, first will be the oxidation state. So -1 oxidation state will be excited by all the halogen atoms. So -1 oxidation will be excited by all the halogen atoms, but except fluorine, remaining all the elements will have +3, +5 and +7 oxidation state. So except for fluorine, +3, +5, +7 oxidation will be excited by all other halogen atoms. +4 and +6 oxidation state are found in oxyacids. So oxidizing power, where fluoride is the strongest oxidizing agent. Fluoride will be the strongest oxidizing agent. So next, the reactivity decreases down the group. The reactivity decreases down the group, like fluorine will be greater reactivity than the chlorine, than the bromine, than the iodine. Next we shall look into the hydrogen halides. Hydrogen halides, where the boiling point will be like, HF will be the greater than the HI, greater than the HBr, greater than the HCl, due to hydrogen bonding. Due to hydrogen bonding, HF will have the greater boiling point and than the hydrogen iodide. So next we shall look into the acidic strength. So acidic strength, same like, hydrogen iodide will be greater than the HBr, greater than the HCl, greater than the HF. So due to decrease in the bond dissociation energy, so due to decrease in the bond dissociation energy, the acidic strength of hydrogen halide will follow this order. So next, reducing character, hydrogen halide will be greater than the HBr, greater than the HCl, greater than the HF. This is due to the weakest bond in the hydrogen iodide. So why the reducing character will follow this order means, due to weakest bond, in hydrogen iodide. Next we shall look into the oxides of halogen family. So where OF2 and O2F2 will be having the -1 oxidation state, Cl2O Br2O will be having +1 oxidation state, ClO2 Br02 will be having +4 oxidation state, I2O5 will be having +5, ClO3 Br03 will be having +6, Cl2O7 will be having the +7 oxidation state. So these oxidation states are very important for your examination. And another important point will be acidic strength of oxides will be proportional to the oxidation state. Acidic strength of oxides will be proportional to the oxidation state. Next we shall know about the interhalogen compounds. What are interhalogen compounds? The reaction of halogen among themselves are called as an interhalogen compounds. So these compounds are covalent in nature due to less difference in their electronegativity. They are diatomic and they are strong oxidizing agent. So next, another important topic in the interhalogen compounds are about its types. So the types of interhalogen compounds will be AB type, AB3 type, AB5 type and AB7 type. So for AB type, CLF and BRF will be the example, and the AB type of interhalogen compounds will be having a linear shape and they will be having sp hybridization. So next, AB3 type examples will be like ClF3, ICl3, and the shape will be T-shaped and hybridization will be DsP3. So next type will be the AB5 type, ClF5 and BrF5 are the example, and the shape will be the square pyramidal and hybridization will be D2sp3. Next, in AB7 type, IF7 will be an example, the shape will be pentagonal bipyramidal and hybridization will be D3sp3. So next we shall look into the what are pseudo halogens and pseudo halide ion. Pseudo means you already know it's an false, the meaning of pseudo will be the false. So some of the pseudo halogens will be like cyanogen, oxocyanogen, thiocyanogen, and pseudo halides will be cyanide, cyanate and thiocyanate. So these are all the important from the group 17 for your Kcet, and some reactions are important in the like preparation of chlorine and all. So you can go through in your textbooks, or as I told in the earlier video, most of the reactions or preparations will not be asked from this chapter. So the other important reactions will be from group 17 or like preparation of chlorine. Now for example, when chlorine is treated with an dilute NaOH in the cold condition, what you will get? So you will get an NaCl plus NaClO and water molecule. Same reaction if it is taken in the hot condition, Cl2 plus NaOH, in the hot condition it forms an NaCl plus NaClO3 along with the water molecule. So this is an important reaction which occurs in the two condition, where one will be the cold condition, another will be the hot condition. So NaCl will be formed common in both the reaction, but in the cold condition you will get an NaClO, in the hot condition you will get NaClO3. So this is one of important reaction in the preparation of chlorine. Next we shall look into the group 18. Next, group 18, they are called as the noble elements. The members will be like helium, neon, krypton, xenon. The electronic configuration will be ns2, np6. They are also called as an aerogens as they occur in the air. So let us look into the properties, where atomic radii will be largest in the period and increases as we go down the group. It is a van der Waals radii and not a covalent radii. This is an important point. It is an van der Waals radii, not the covalent radii. So next property will be ionization enthalpies are highest in the period due to stable configuration. Due to stable configuration, as we go across the period, ionization enthalpy will be greater. As we go down the group, ionization enthalpy will get decreases. So next, electron gain enthalpy is 0. Electron gain enthalpy is 0. Why electron gain enthalpy is 0? Due to the completely filled valence shell. Due to complete filling the valence shell, the electron gain enthalpy will be 0 in the group 18. So next, boiling point and melting point increases as we go down the group. They are sparingly soluble in water. They are partially soluble in the water. So next we shall look into the xenon, where xenon forms binary fluorides like XeF2, XeF4 and xenon hexafluoride. And here are the reactions which are very important. Like when a xenon is reacting with a fluoride, or sealed in a nickel vessel as a 2:1 ratio at 673 Kelvin, it gives an xenon difluoride. Again, xenon reacting with filled with a nickel vessel along with the fluoride in 1:5 ratio at 873 Kelvin, you will get an xenon tetrafluoride. So xenon plus F2 sealed in a nickel vessel as 1:20 ratio. As 1:20 ratio at 573 Kelvin, you will get an xenon hexafluoride. So next we shall look into the molecules of xenon. So like xenon F2 will be having the sp3d hybridization and the shape will be the linear, where xenon F4 will be having sp3d2, the shape will be the square planar. Xenon F6 will be the sp3d3 and the shape will be the octahedral. Next XeOF2 will be sp3d hybridization and the shape will be the T shape. Next XeOF4 will be the sp3d2, square pyramidal will be. Next XeO2 will be the sp3 hybridization and shape will be the pyramidal. So these are all the molecules of xenon and their hybridization and the structures. So next, uses of the noble gases. So as the mixture of 20% of helium and 80% of oxygens are used by the deep sea divers. Okay, na? So 20% of helium and 80% of oxygen are mixed together and used by deep sea divers for an artificial respiration. Next, neon is used in discharge lamps and signs. They are also used in signs. So next, radon is used in the treatment of cancer like radiotherapy. Next, oxygen and helium as in 1:4 ratio. So the mixture of oxygen and helium at 1:4 ratio is used in the treatment of asthma. It's used in the treatment of asthma. So these are all the uses of noble gases and important topics and points for your Kcet examination. Thank you all.